Continuing on with the orientation parameters for branches. The next parameter that we have is the orient branch to its roots. If I uncheck this, it means that the branches are going to have their orientation, which follows the swivel angle, regardless of the parent orientation. So to illustrate this more clearly, I'm going to go to branch level 1 and I'm going to increase the turbulence. So if I go to branch level 2, I'm going to decrease the turbulence over here so we have a clearer view. If I set the swivel value to 0 and the point to tip value to 0 as well, I'll set the spin branches to 0 and the spread angle to 90 degrees. The branch tilt, I'll set it to 0, and the horizontal branches are set it to 0 as well. So now we see that the branches are pointing downwards regardless of the parent orientation. I'm going to increase the branch segments to 20 or 30 so that we see the orientation properly displayed. Now here I'm going to reduce the branch pruning to a value of 0.4. So if I increase the swivel, the branches are going to swivel out according to their own orientation without taking the orientation of the parent into consideration. If I check orient branch to its root, then the branches are going to take the parent orientation into consideration. So if we look at this parent branch here, we see that the child branches take the orientation of that parent branch to orient themselves. If I uncheck this, the orientation of the parent branch is not considered at all. So when do we use the orient branch to its root parameters and when do we not use it? Actually, we do not use it in most of the cases because we want the branch distribution to be even. If we check it, then the orientation of the branches is not going to be even, and therefore the tree is not going to look that much natural. In case I was creating a very chaotic tree, then I would probably use it. Otherwise, I would leave it unchecked. So if you look here, we see that the distribution of the level 2 branches is uniform, while if I check it, then the distribution of these branches is not uniform at all. So it's up to you to decide whether you want to use it or not, but bear in mind that for a uniform distribution, you should uncheck it. The next parameter I want to talk about is the branch turbulence and turbulence scale, and these are easy to understand. I can increase the turbulence, which will turbulence the shape of the branch, and I can play with the scale. If I reduce the scale, then I would get more detail and therefore smaller deformation sizes. If I increase the scale, I'm going to get less detail with bigger deformation sizes. If I set the turbulence down to 0 and I increase the branch waves in the X, I'm going to get wavy branches in the X axis. If I increase the Z, I'm going to get wavy branches on the Z axis. If I set them to equal values, eventually I'm going to get spirals. I can change the wave scale. If I reduce it, I'm going to get spirals, but then I would have to increase the branch segment count to get the spirals displaying properly. Now, in case you do increase the waviness and the branch segments and you get twisting along the meshing of the branch, what you need to do to fix this problem is to go to tree parameters and go under adjust meshing, and here you can increase this value to actually fix the up vector of the orientation to unwind the twisting. This is only necessary whenever you have a lot of tiny deformation in the branch and you are really shooting from a close range. The wave offset value will offset the wave, which will create the impression that the wave is moving along the branches. The next parameter is the length of the branch, which you can increase and decrease. If you do increase it though, don't forget to increase the branch segment count to get smoother branch meshing. Next, we have the length variance value, which you can increase to actually vary out the length of the branches. The next parameter is the branch radius, which you can increase and decrease, followed by the reduced radius on branch and the inherit parent radius. So if you look over here, we see that this branch of level 2 is not really coinciding with the tip of branch level 1. To fix that problem, I'm gonna increase the radius for level 2 like so. Now, if I increase it, I see that also the first branches were increased in radius, and therefore I got the branches sticking out from where they need to. So instead of doing that, I'm gonna go to my reduce radius on branch, and I'm gonna reduce that value so that the reduction of the radius does not happen over the branch. But I need to see this from the top as well. So you always fix it from the first branch, and you see the rest of the branches, especially from the top branches, whether they work or not. For this, I'm gonna increase the inherit parent radius to fix the radius at the top branches. So once you have fixed it at the base and at the top, then all the other branches would work as well. Another thing you can do is go to branch level 1 and increase the tapering over here. This is only necessary in case you are shooting from a close range. Alright, so now it seems that all the branches are fixed properly. So what you need to work on is the tapering of the parent branch, which is this value in this case, and then the reduce radius on branch and the inherit parent radius. So the difference between the two is that the reduce radius on branch will reduce the radius on the branch, just as the name suggests, while inherit parent radius will reduce the radius according to whether the parent was reduced or not. The next parameter is the tapering value. So we are at branch level 2. You can increase and decrease the tapering like so. And remember that the tapering is controlled globally under branch global by the branch taper bias. If you reduce that, it means that the branch tapering is not going to happen too fast, while if you increase it, the tapering of the branch is going to happen close to the base of the branch. So that's the branch tapering.